All right, hello everyone, and welcome to this week's MetalCon Online. This week's webinar will be presented by Amanda Turner with Cornerstone Building Brands on building a sustainable future, navigating the environmental challenges in PEMB. Before we get started, I did just want to cover a few important pieces of information. So MetalCon's housing hotel block is now open. We do have 6 contracted hotels that will book up quickly. So we want to be sure everyone knows to book your accommodations early at metalcon.com/hotels to make sure you get all the accommodations necessary. I did also want to mention our next MetalCon Online will be taking place May 1st. The topic is about understanding and explaining the energy efficiency and condensation dynamics of metal roof and wall panels. Be sure to check out this course and keep an eye out for all additional upcoming webinars on our website. I did also want to mention that registration is now open. To take advantage of the lowest possible prices, you will want to register by May 10th. To get our Super Saver discounts. So this year, MetalCon will be October 30th through November 1st in Atlanta, Georgia. Super Saver pricing will be until May 10th, and we hope we will see you all there. And finally, I did just want to let you all know to fill out the survey that you will receive in a separate email after this webinar to make sure that you receive your credit and your certificate of completion. And now I will let Amanda begin.
Good afternoon, and thanks for joining me here today. I'm excited to talk to you about the fascinating world of sustainability in pre-engineered metal buildings. So my name is Amanda Turner, and I'm excited to delve into the fascinating world of sustainable construction, specifically focusing on the challenges and opportunities associated with building using pre-engineered metal structures. I have 14 years of experience in energy management and sustainability, most recently in construction and steel buildings. And I've had the privilege of witnessing firsthand the transformative power of sustainable building practices. Throughout this presentation, we'll explore not only the innovative design aspects of pre-engineered metal buildings, but also their profound impact on environmental conservation, energy efficiency, and responsible resource management. So let's dive in and discover how these structures are shaping the future of construction while preserving our planet for generations to come. What we're going to learn today is the ability to identify key sustainability attributes in pre-engineered metal buildings and how these attributes contribute to the improvement of the built environment. You're going to be able to summarize the key sustainability best practices associated with pre-engineered metal buildings, with a focus on integrating sustainability principles into design and construction phases. You're going to be able to discuss metal building case studies and explore the best practices associated with each as they attempt green building certification. And lastly, you'll be able to describe how to advocate for and educate others on sustainable practices in the pre-engineered metal building industry. So we're going to start with a brief introduction. And then we're going to go into sustainable construction and pre-engineered buildings. We'll then talk about best practices, moving into education and advocacy, and then closing out with sustainable metal building case studies. Sustainability in construction refers to the practice of designing, building, and operating structures in a way that meets the needs of the present without compromising the ability of future generations to meet their own needs. It involves a mindful approach that considers environmental, social, and economic aspects throughout the entire life cycle of a building. From an environmental standpoint, sustainable construction aims to minimize the impact on natural resources, reduce energy consumption, and promote the use of eco-friendly materials. Social sustainability involves creating spaces that enhance the well-being and health of occupants, while economic sustainability focuses on long-term cost effectiveness and effective resource utilization. In essence, sustainable construction is about creating buildings that are environmentally responsible, socially equitable, and economically viable. It is a commitment to balance the triple bottom line: people, planet, and profit, resulting in structures that contribute positively to both the immediate community and the global environment. A pre-engineered metal building is a type of building structure that is designed, fabricated, and assembled using standardized components manufactured off-site and then transported to the construction site for assembly. These buildings are engineered to meet specific design requirements and are typically used for commercial, industrial, agricultural, and institutional purposes. Some of the key features of pre-engineered metal buildings is the standardized components, which are manufactured according to predefined specifications, customizable design, which can accommodate various styles, sizes, and functions, efficient construction, faster and more efficient compared to traditional buildings, durability and strength, resistant to adverse weather conditions, fire, and pest. And most importantly, sustainability can be designed to incorporate sustainable features. Despite all of those great attributes, there's also cost effectiveness, often resulting in cost savings compared to conventional construction. As the global focus on sustainable building requirements intensifies, metal buildings stand out as leaders. Pre-engineered metal buildings can be designed to incorporate sustainability features such as energy efficient insulation, daylighting systems, the integration of renewable energy and recycled water sources, and the use of recycled materials, contributing to environmental sustainability. You may have heard of green steel. Well, there are indeed green features of pre-engineered metal buildings, due mainly to the fact that steel is the major component in pre-engineered metal buildings. Steel has a higher strength to weight ratio than any other building material. That means fewer resources and materials are needed to build a steel structure to handle the same amount of load or stress as other building materials, such as wood. Steel is also 100% recyclable at the end of its life, and 630 million metric tons of steel are recycled every year. That recycled steel, on average, contains 79% recycled content when produced in the electric arc furnace. Additionally, steel buildings can be fabricated to exact specification, minimizing waste, and component parts can easily be deconstructed and repurposed or recycled. Because of the prefabrication process, you've decreased your transportation and construction time, leading to reduced carbon emissions and material waste. Design flexibility encourages energy efficient practices such as insulation, solar panel installation, and natural lighting that can lower energy costs. Pre-engineered metal buildings are designed to be energy efficient. They can incorporate advanced insulation systems to enhance energy efficiency, and proper insulation helps in maintaining desired interior temperatures, reducing the need for excessive heating or cooling. Many pre-engineered metal buildings use cool roof technologies with reflective surfaces to minimize heat absorption. This contributes to lower indoor temperatures, reducing the demand for air conditioning and improving overall energy efficiency. Well-designed pre-engineered metal buildings often incorporate features like large windows and skylights for natural daylighting. Natural ventilation strategies also help reduce the reliance on artificial lighting and mechanical ventilation systems. Some pre-engineered metal buildings incorporate renewable energy sources, such as solar panels, to generate on-site electricity. This can offset energy consumption from the grid and contribute to a more sustainable operational phase. And lastly, thermal mass features in pre-engineered metal buildings help regulate indoor temperatures by storing and releasing heat. This can contribute to a more stable and energy efficient indoor environment. So how does steel compare to traditional building materials? In terms of perceived sustainability, there are several sections where steel is considered more sustainable than concrete or wood. However, when it comes to raw material carbon content, steel production is very energy intensive compared to wood. And although there are some sustainable alternatives, these alternatives may be costly. All steel products and wood siding products incorporate recycled content, but concrete and wood framing do not due to material and performance requirement constraints. Additionally, LEED certifications driving buildings to optimize many material aspects. The type of material can affect the overall efficiency of a building. Steel is easier to maintain over time and tends to have a significantly longer durability than wood in particular. And when it comes to the end of the steel building's life, recycling at commercial sites is more common as large companies seek LEED certification, with steel recycling more mainstream than wood. Concrete is typically not recycled into new wall panels, but can be recycled for other uses. So now that we've discussed the attributes of pre-engineered metal buildings, we are going to move into the sustainability best practices with pre-engineered metal buildings. The first step is sustainable sourcing. Procuring environmentally friendly materials for pre-engineered metal buildings is a key step on the path to desired sustainability. When you are sourcing your steel, source steel with a high recycled content or from responsible mining practices. Verify the sustainability claims of material suppliers. Certification standards, such as those for recycled content or responsible sourcing, may vary. Try to locate suppliers with environmentally friendly transportation practices and sourcing materials locally. And finally, balance sustainability goals with budget constraints. Once you get your steel, you're going to want to focus on using recycled steel. Using recycled steel in construction significantly reduces our carbon footprint and conserves valuable resources. Recycling steel cuts CO2 emissions by up to 86% compared to primary steel production. Every ton of recycled steel saves approximately 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. Recycled steel also saves between 60 and 74% of the energy used to produce virgin steel. Recycling steel reduces the burden on landfills and mitigates environmental pollution and degradation. Through recycling, the steel industry saves enough energy to supply the annual electricity needs of more than 18 million homes. And how do they do that? It starts with the production of steel. Steel, which is a fundamental material in pre-engineered metal buildings, is energy intensive to produce. Extracting iron ore, refining it into iron, and then producing steel involves multiple energy intensive steps. It's essential to acknowledge the energy intensive nature of steel production and fabrication processes in pre-engineered metal building manufacturing. Sustainable practices can help mitigate these challenges, such as using recycled steel and optimizing manufacturing efficiency. Additionally, incorporating energy efficient technologies in manufacturing facilities can contribute to reducing the overall environmental footprint of pre-engineered metal buildings. We have become much more energy efficient in the last few decades than we were previously. Energy management improvements in steel production have resulted in reductions of nearly 60% energy consumption since 1960. Producing a ton of steel today in North America requires less than half the energy that was needed to produce a ton of steel 40 years ago, resulting in a 50% reduction in greenhouse gas emissions. That means that a single ton of steel produced today compared to 1980 would save the greenhouse gas emissions equivalent to driving a car for 2,000 miles. This decrease in energy consumption can mostly be attributed to an increase in the share of electric arc furnace production and more recycled scrap use in basic oxygen furnaces. Energy efficiency improvements also played a role, which was primarily due to a move to almost 100% continuous casting in this time period, as well as energy efficiency improvements as new electric arc furnaces were built. Technology development is also underway to provide an infrastructure capable of supplying renewable electricity to help enable the industry to decarbonize its operation. Technologies for efficiency improvements are essential tools to compete in an ever-expanding global market. While steel tends to have a significantly longer durability than other construction materials, such as wood and concrete, it will eventually reach the end of its useful life. Steel is one of the most recycled materials in the world, and recycling metal components from pre-engineered metal building requires stakeholder collaboration during all phases of construction. Specifically, the deconstruction process to dismantle pre-engineered metal buildings can be intricate, especially if the original design did not prioritize ease of disassembly. You may also have issues with transportation of dismantled metal components to recycling facilities, and you may incur environmental costs. However, can you hear me?
I can hear you.
Okay. All right. Thank you. Sorry about that. So now we're going to talk about how to advocate and educate others on sustainability in the pre-engineered metal building space. Sustainability advocacy is integral to the PEMB industry as it aligns with environmental responsibility, resource efficiency, cost effectiveness, regulatory compliance, and the growing demand for eco-friendly construction solutions. It positions the industry for long-term success while addressing global challenges related to climate change and resource depletion. This can be achieved by several different methods. Know the environmental impacts. Pre-engineered metal buildings, like any construction projects, have environmental implications. By advocating for sustainability, we can help mitigate the industry's ecological footprint by promoting eco-friendly materials, energy-efficient designs, and responsible waste management. Conserve your resources. Sustainable practices encourage the efficient use of resources. Advocacy can drive initiatives to reduce material waste, optimize energy consumption, and promote the use of recycled or recyclable materials in pre-engineered metal buildings. Sustainable building practices contribute to the long-term viability of the pre-engineered metal building industry. By adopting environmentally responsible approaches, the industry can adapt to changing regulations, consumer preferences, and global sustainability goals. Sustainable practices often lead to cost savings in the long run. Energy efficient designs, the use of recycled materials, and waste reduction measures can result in lower operational cost and increased overall efficiency. In the market, we're seeing more of a demand as sustainability gets more of a reputation. Many consumers and businesses are prioritizing sustainability. Advocating for sustainable practices in the pre-engineered metal building industry responds to market demand for environmentally conscious construction. It also enhances the industry's reputation and competitiveness. But of course, there are always rules, and environmental regulations are becoming more stringent. By advocating for sustainability, we are ensuring that the pre-engineered metal building industry stays ahead of regulatory requirements. And by advocating for sustainability, we are also aligning with achieving certifications such as LEED, Leadership in Energy and Environmental Design. This not only demonstrates a commitment to sustainability, but also enhances the recognition and marketability of pre-engineered metal building projects.
Hi, Amanda, I'm just gonna cut you off for 1 second. It looks like in the Q&A, it says that the slides don't appear to be changing. I just want to confirm which slide you're on and see if we're having an issue on our end.
I am on Innovation 19.
Okay, yeah, we're still on Voices for Change. Oh, there we go. It's moving.
Can you see advocating sustainable construction?
No, I still see Voices for Change.
Hold on. All right, can you see it now?
I can see the PowerPoint, but we're still on Voices for Change.
Okay, so we're on Voices for Change, yes?
Yes.
All right, and then if I do this, does it go to? I apologize for the technical difficulties. Here we go. Can you see that now?
I see Building Minds and Building Futures.
Perfect.
Okay,
All right.
awesome.
All right. So All right, so in order to advocate for sustainability, you also have to educate for sustainability. In order to educate on the environmental impact, you have to understand the impact of the construction activities and materials used in pre-engineered metal buildings. You need to be able to identify and select environmentally friendly materials for pre-engineered metal buildings. You need to be able to integrate energy efficient design principles and implement strategies to reduce construction waste during the manufacturing and installation phases. Understand the technical and economic aspects of integrating renewable energy solutions into pre-engineered metal buildings. Be familiar with national and international green building codes and standards, staying updated on emerging regulations related to sustainability and construction, and keep abreast of technological advancements in sustainable construction practices. Now, you can't talk about educating for sustainability or advocating for sustainability without talking about LEED. LEED was first piloted in 1998 and is now the most widely used rating system in the world for green buildings. It is a voluntary framework for healthy, highly efficient, and cost-saving green buildings based on industry standards. As of 2023, more than 185,000 LEED projects, representing over 28 billion square feet, had been proposed worldwide, and more than 105,000 projects representing over 12 billion square feet had been certified in 185 countries. In terms of pre-engineered metal buildings can help contribute to LEED credits. There are several LEED credit categories where the use of a pre-engineered metal building can assist in earning credits. So in order to have a sustainable circular lifestyle, you have to close the loop between sourcing your steel and end-of-life disposal. By implementing proactive strategies and collaborative efforts across various stages of the building life cycle, it is possible to improve the environmental impact of pre-engineered metal buildings. Excellent. Do we want to stop there for questions? All right, great. Now we will move into sustainable metal building case studies. These are buildings that used either part or all metal building construction and were able to achieve LEED certification. The image on the screen is known as the most sustainable airplane hangar in the world. Hangar 25 opened in December 2008 and is the world's first airplane hangar to achieve platinum certification under USGBC's LEED rating system. Hangar 25 has also been awarded the Environmental Management Award by the Airports Council International North America. The hangar was designed to offset aircraft cabin emissions, incorporating a solar-powered roofing system that runs all electric vehicles and office operations, totaling 110% of the building's energy needs. The LEED Platinum Hangar 25 also features low water plumbing fixtures, native plant landscaping, and low maintenance diamond polished concrete flooring. It employs natural daylighting and a large propeller ventilation system. Its innovative water mist fire suppression system is the first of its kind in the US and uses significantly less water than an ordinary system, while also avoiding hazardous chemical transmission. 48% of the materials used in construction were obtained locally, and 77% of construction waste was recycled. So when you think of metal buildings, do you think of advanced structural testing labs? Probably not, but this project is comprised of 3 buildings totaling 75,000 square feet and is part of Auburn University's engineering department. The structures are used as a testing laboratory for structural components used in engineering. This LEED certified project incorporated 5 different metal wall and roof panels, which were used over conventional and pre-engineered metal building construction. A 40-ton overhead bridge crane was installed inside one of these structures. Rainwater is collected off building roofs and stored in a 3,400-gallon rainwater cistern for reuse. The building design reduces energy costs by 20.7% and is expected to save Auburn University $10,577 each year. Along with being LEED certified, the Advanced Structural Testing Lab has also been recognized by AIA and the American Council of Engineering Companies of Alabama. Next, we're going to talk about this state-of-the-art winery production facility in Paso Robles, California. It's 60,000 square feet, state-of-the-art winery production facility is a hybrid building system. Many sustainability features went into its construction, including prismatic skylights, roof deck panels, and insulated concrete walls. It was awarded the LEED Silver certification. The roof deck panel combines into a single component steel deck insulation and substrate necessary for white single-ply membrane or non-structural standing seam roof coverings, an economic alternative to rigorous and expensive field-assembled roof deck systems. The roof is a cool roof, a roofing product that reflects more sunlight and absorbs less heat than a traditional roof. This keeps the building cooler during the warm seasons and warmer during the cool seasons. Coming in next at LEED Gold is Audubon National Wildlife Refuge in Cole Harbor, North Dakota. To achieve the main focus of functionality and sustainability, the roofing contractor worked with a Houston-based company for the roofing panels. 16,000 square feet of standing seam roof panel was used. The high-strength system was selected to resolve serious health and safety problems the building had acquired and earned LEED Gold certification in the process. Finally, we come to LEED Platinum, Sweetwater Sound headquarters in Fort Wayne, Indiana. Sweetwater is one of the leading e-retailers of musical instruments and equipment in the world. The Sweetwater campus headquarters in Fort Wayne was one of the first 200 buildings in the entire world to become LEED Platinum certified by USGBC following its initial construction. Their headquarters is only the second building in Indiana to achieve LEED Platinum, placing the Sweetwater campus among the nation's most environmentally friendly. This project was completed in 2 phases using custom pre-engineered metal buildings. Sales offices are clad in bamboo, and other rapidly renewable materials were used throughout the facility. A reflective white roof and insulated heat-treated glass is used on the building to reduce solar heat gain and limit the cooling load placed on the building's mechanical systems. Light sensors automatically adjust the amount of light as necessary, and roof insulation increases energy efficiency. So as you can see, the green attributes of pre-engineered metal buildings lend themselves very well to green building certifications. In conclusion, we can say it is possible to build a sustainable steel future. By being environmentally conscious, we can understand the profound impact of pre-engineered metal buildings on the environment. We can embrace the responsibility to reduce the ecological footprint in construction practices. By knowing your materials and navigating material choices wisely, opt for sustainable alternatives. Make informed decisions to promote resource efficiency and reduce environmental impact. For the architects out there, design for efficiency. Apply energy efficient design principles to enhance the performance of pre-engineered metal building projects. Optimize natural resources, contributing to long-term operational sustainability. And for all you contractors out there, practical implementation. Implement waste reduction strategies and incorporate renewable energy resources. Foster social responsibility and community engagement. And when we do that together, what heights can we reach? So the next steps in your pre-engineered metal building sustainability journey: continue learning. Stay informed about evolving sustainability practices and technologies. Engage in ongoing education to remain at the forefront of sustainable construction. Collaborate with stakeholders in the pre-engineered metal building industry. Work collectively with them to address sustainability challenges and drive positive change. Advocate for sustainable building practices within your professional sphere and take actionable steps towards building a resilient, environmentally conscious future. Your commitment to sustainable practices in the pre-engineered metal building industry is a vital contribution to a greener, more sustainable future. Thank you. I have time for questions if anyone has any.
Hi, Amanda. A question did come through in the Q&A section. Someone asked, where can I get more information on metal buildings and sustainability resources?
So a good place to go if you're looking for sustainability resources for pre-engineered metal buildings would be the brand websites, but you can also visit Metal Building Manufacturers Association. Many of the building manufacturers are a part of that association and will have data and information and resources related to that. All right. Well, I thank you very much for your time. I'll turn it back to you.
All right. Are there any last minute questions that are going to come through for Amanda? All right, then. If not, I just want to thank Amanda again for her presentation. It was great, and this will be on our on-demand and YouTube channel. And a survey and email will go out to all of you after this webinar to have you fill out the survey and get your credit.
Thank you.